This tyre and this tyre might look identical, but there is a huge difference between them when it comes to the performance and comfort you have when you're out riding your bike. So to find out if more expensive tyres are actually better and dive deep into the subject of tyres, I'm going to speak to Sam Bressan, who's a tyre expert and is the head of global marketing at Pirelli. In this interview, I want to find out what the next big thing is in tyre technology, why cheap inner tubes are killing the performance of your expensive tyres, why tyres are getting wider and wider, how bike tyres can actually be recycled, and we'll of course be discussing hookless. So grab yourself a drink and get comfy. Essentially, I thought I wanted to speak about how we can allow people to differentiate between good tyres and bad tyres, because I don't know, somebody walks into a bike shop or they're looking online, how on earth can they tell what's good from what's bad? Because all tyres are pretty much within reason look the same. So how can we provide information to help people? Where can we start?
Well, the easiest is probably the most intuitive, even though there is something to take care, which is the price. So it's defined as many products, it's defined by the price. So the higher normally, the better. With one exception, I would say, that is if a consumer prioritise by much the puncture protection and the robustness of the tire as a whole, then it's not necessarily true that the most expensive is also the most protected or the strongest. Let's put it this way. There are tires which are very expensive, which are also very protected, and usually they come with protection plus other properties like grip, comfort, rolling resistance, name all of them all together. But it's also true that a cheap tire, while it loses all the other properties, normally grip is not good, comfort so and so, but it stays robust.
So if you were to break down the different areas of a tyre, what would be the areas that are most important if we looked at the tread in isolation or the compound or the casing?
Well, I would say it would have been an easier reply if we were talking about moto or car tires, because in that sense, the rubber itself plays the biggest role. So the majority of the performance comes out from the rubber. With cycling tires in general, and I'm saying all of them, regardless if they are road, gravel or mountain bike tires, because everything is so thinner, there is much less rubber in proportion to the textile material, which is the one that makes up the casing. So it's also always a trade-off between the rubber properties and the nylon casing. Normally it's nylon with some exception if you have other materials like cotton. But I would say that it's how the two of them works together. So it's the rubber formulation has to be designed in conjunction with the properties of the textile that you have underneath.
Okay, so
I was 50-50, I would say.
Okay, so when it comes to things like the weight of a tyre, how important is that in terms of how it's going to impact like people's riding characteristics?
It's very important, and I would say it's probably underestimated also by tire manufacturers themselves. And I'm talking as one of them. We see that the impact the weight has on the handling, general handling perception, it's very evident, more than the data that maybe you take out of laboratory testing. So when I'm talking about you can measure the grip, you can measure the rolling resistance, you can measure the vibration absorption, but we always see that the perception that the rider has on the tire, on the outdoor, has a bigger correlation to that than the pure numbers that you take out of the laboratory. So the lighter the tire, the better it is always the feeling that you get out of it. And it's a feeling in terms of either shock absorption, perceived grip, and even perceived rolling resistance.
And that feeling is, like you say, near impossible to quantify because everyone's feelings on the bike are going to be different.
Yeah.
But it's perhaps arguably one of the most important, because you want to go out on your bike and you want to feel confident with what you're doing and you want to feel happy.
Yes, definitely. And I take an example which comes, it's very easy for motorsport, but it also works the same in bicycle. We as a brand, I mean, all the brands which are involved in racing specifically, they can recognize that the athletes, whether they are pilots on motorsport or cyclists, they always look more of being in control of the limits, whether they are grip limits usually. They are more concerned about that than of the peak performance of the tire. So they are always requesting the capability to use the 100% of the grip and to feel how far they are from that limit, more than move that limit higher in terms of peak. The example is they prefer a tire which has allows to corner with a less of an angle, for example. So a little less in terms of maximum leaning that you can do, but you can approach that feeling how far you are from that limit. So it's much more effective, the feeling that you get out of the tire, because it's what allows you to use the 100% of the tire performance. So this is priority number one for all the racing products, and it's difficult to achieve. I mean, you have to work a lot more to achieve the whole package of characteristics to give that feeling to the athletes. While if we would concentrate on just one or two performances which you can measure, like maximum grip or maximum rolling, it's relatively easy. But allowing that feeling to be perceivable, it's much more difficult.
It feels like tyre technology gradually has evolved over the period of time. Tyres have got faster, lighter, more resistant to punctures. But do you think there's a big change that we're going to see on the horizon? Do you think in 10 years' time we'll be sat talking about tyres in a completely different way?
I wouldn't say there are no massive changes at the horizon. If not, starting to use sensors in bicycle tires as well. It's something that in automotive is happening already. I mean, it's not at a larger scale, of course, but it's happening. So tires that measure what's happening and communicate data to the CPU of the car, it's already a reality.
From your perspective as a tire manufacturer, how has hookless technology changed how you approach creating a tire?
It makes a difference in production tolerances. So I go straight to, let's say, technical detail. And now I jump back on the concept. I mean, the hookless thing, as in theory, it's perfect. So nobody argues against it. And it's fair to say that all other vehicles, whether they have 2 or 4 wheels with a motor, they already are on hookless. So everybody, and when you think that airplane, trucks, automotive, they all go on hookless, you understand that there is no discussion in that sense. Bicycle is a different thing because of the weight, basically. So everything has to be kept as light as possible because there is not a motor which is pushing behind. So the compromise between the energy input into the system is it's always first in priority because all the energy comes from ourselves. So this changes the approach. Long term, I think the hookless is going to be the point of discussion, and where the critical problems and issue comes from is how long the industry of either rims and tire manufacturer will need to become 110% reliable with all the different application and with all the different possibilities of coupling one tire with another rim. So that has still a long way to come because there is no mandatory rules behind.
So if you had a P0 TLR, and if you've got it, a hookless compatible version and a non-hookless version, like what is the difference between the tires? Is it purely down to the bead construction?
99.9% happens at the bead. So it's the way you manufacture the bead. So it's either at 3 level, the materials that you choose, which have a certain amount of strength, elongation, and all those properties. So you choose them by the target that you have to achieve, being hookless or not hookless compatible. Then there is the manufacturing tolerances. So having a manufacturing process that makes sure that 100% of the products are within the tolerances which are lower, because the whole point is how the bead interface with the rim wall. And then there is also some area of play with the geometry of the bead itself. So the shape, the cross-section shape that it has, because you have to interact with a wall of the rim, which is completely straight. So there is not that hook, which is there for a reason. So let's be also honest, is there to help the retention of the tire. It was mandatory for the last 50 years, by the way, and the tolerances that the whole bead diameter needed. Now we are able, as a whole industry, to manufacture things either at rim side and tire size to be reliable, but we are in the process to align all of us.
So hopefully in the coming years, we'll see everything locked down a bit more firmly.
Yeah, for sure.
There are some other sort of terms that I think it would be nice to get some clarity on, because I think some technical terms which can seem confusing to some people. So if you could give us a real quick, simple explainer, things like what does CRR actually mean?
Yeah, this is a number. It's a pure number, so it's not describing a dimension in terms of watts or energy. It's a number that correlates the amount of energy which a tire is basically absorbing. So it's strictly related to the rolling resistance, of course, and it's used to compare different rolling resistance. But it's worth to remember that it's not a physical dimension. It's only a number. And because of that, it has a meaning only within a testing session. So at a given speed, machine, load of the tire, then the CRR is a comparable number between different tires under the same condition.
What about tire hysteresis? This is something I hear lots of people talking about when we're trying to talk about the efficiency of a tire.
Yeah, it's probably the most fascinating word I hear that being used a lot. It's related in particular to the rubber itself. So describes basically the amount of energy that the tire absorb or release, depending on how high or low is the hysteresis, while deformating. So it's about the deformation. When you deform the tire, and deformation happens in the footprint. So every time the tire rolls and touches the ground, deforms to conform to the flat area, which is the footprint itself. That deformation as an amount of energy absorption, which is described by the hysteresis word. Is normally a number which describes higher or lower hysteresis. It means that the tire absorbs more energy, which is normally transferred to heat.
Okay,
so in bicycle it's very low, so you cannot really measure the heat. Yeah. But in reality, by deforming, it warms up.
So a lower number would mean that the tire is using less energy effectively?
Normally, yes. Yes. There is a way to describe internally to the rubber compounders of a tire being warm or cold. So, because it releases less temperature or more temperature with a higher hysteresis, it's warmer, they say, because this transfer more energy into heat, while a colder rubber formulation generates less heat while deformating.
So, following on from that same type of subject is something that lots of different brands and wheel companies will talk about, is vibrational losses. Because I think some people testing tires will discuss tire hysteresis and vibrational losses, and other people will talk about it as one sort of concept. So give us a bit of more of an explainer about it, basically.
It becomes a bit more complicated because we have to talk about the frequency. So we have to factor in another concept, which is the frequency. So how quickly those deformation happens. Normally, as low deformation is considered everything which is below 60 hertz. so one deformation per second. Vibrational losses is more about higher frequency deformation, so something that it's measured at very not super high frequency, to be honest, in absolute sense, but at a higher frequency. But it's directly correlated to the hysteresis. It's again another way, another frequency of the energy loss, of measuring the energy loss in the sense. Has a lot of implication. Probably the most intuitive one for us cycling is the time the rubber stays in contact with the ground, because the higher or lower frequency, the more you have a contact patch, which is in reality all the time in contact with the ground itself. You play a lot with it. The biggest parameter, the easiest parameter to influence the vibrational losses is the inflating pressure, of course. But then it's the whole system of tire plus rim plus spokes, suspension, and the frame all together, which contribute to it. Why, for example, hysteresis is rubber by itself.
Yeah, I think people automatically assume that just because a tire's pumped up really hard, it's going to mean that it's fast, but there's so many different factors to contribute to it. So I think by now, I think lots of people are aware that generally the advice from the bike industry as a whole is that wider tyres at slightly lower pressure could be advantageous for most riders. It could make your bike a little bit more comfortable, it could help you ride a little bit faster, and it can increase the grip that you could have from your tyre. So why is it that wider tyres at lower pressure? Because is it a common misconception that it's to do with the volume inside the tyre? It's more a case of talking about the tension on the casing.
Yes, the tension is a thing. Generally speaking, I would say that there are all advantages in the real world. So I always like to start and remember that the physics are always the same. So in a situation where the surface is really smooth and solid, like into the laboratory, or like I always make the example of the railway, because it's easy to get. A train goes on rails, which has no tire, has a solid steel wheel, which goes on a solid, very smooth piece of steel. So that's still true. In the real world, in cycling, this happens only in a velodrome, normally, where you have very smooth pavé. So in that situation, still the higher the pressure, the better it is. But then all the rest of cycling happens in the real world, where even the tarmac surface is far from being really smooth. And I'm talking nice and well-fitted tarmac. They have a roughness which is relevant already in terms of energy and hysteresis and vibrational losses that we mentioned. So with which the real world, then the quote that wider tires are better becomes absolutely relevant, because they provide all the benefits that you mentioned. Within it, digging more into details within it, there is one properties which is counterintuitive, or maybe is neglected from the main communication, which is the tension of the textile by the crown. I know that it's sometimes addressed as a spring rate. It means the strength and the kilograms which the textile around the crown, it's pulled from one side to the other, which looks and seems a complicated concept, but it is the one that gives the thumb test feeling. So when you push with your tire, with your thumb, especially a road tire, so that there are no big knobs that squirms, you are basically feeling more the tension of the casing itself, more than the pressure, which is a dimension which pushes from the inside out on all directions. So it's a combination of those two. And the textile tension, it's influencing a lot. And normally this becomes bigger with the bigger volume. So the longer the crown is, at the same pressure, the higher is the tension that those textiles, single threads of nylon, are pulled from. And this is normally higher.
Yeah, that makes a lot of sense, because I think it's easy to, like you say, it seems confusing, but when you explain like that, it kind of makes perfect sense, because you've got the casing is linked from side to side by the tire beads.
There is an easy test that everybody can do. If you take a mountain bike tire of 2.4 and you pump it up at 3, but I wouldn't go more than 3 because probably it's going to be higher than the maximum pressure, but 3.5 bar, and you try to push it, it feels rock solid as a road tire of 25 millimeter pumped up at 9 bar.
Yeah.
Even though we are talking 3 to 9, but the feeling that you get if you try to squeeze them, it's really similar. While pressure itself is 3 times more one to the other. So you do not feel that 3 times more because of the tension of the textile, which in the bigger tire at 3 bars is as close, is very, very similar to the one of a smaller tire at 9 bar in terms of test. And this is something that everybody can go down in the garage and test.
Yeah. If you were to design a tire from scratch, what are the areas and characteristics which you would prioritize as being the most important? So let me give you some examples. So you've got the casing, structure, the rubber compounds, the puncture protection. Like, how would you rank these in level of priority from a manufacturing point of view?
Well, it has to start before the manufacturing, the technical part, addressing the question of who you are designing the tire for. That's as simple as it gets. If I'm designing a tire for a work tour racer or for a daily commuter, the whole development phase will be completely different, of course. This is the job that happens normally, I think, in all the companies, more at product management or marketing and sales level. And this is by a large factor what defines 90% of the technical characteristics, because it's all a consequence of that initial choice. Then once you have identified who you are designing the tire for, you get the first 3 normally priorities. Like it can be rolling resistance, grip and weight, if it's for a racer, or can be puncture protection, comfort and mileage, if it is for commuting, for example. So you always tend to focus on the first 2 or 3, and then the others comes as a consequence, because it's all a game of compromises between all of the different characteristics. So you have to decide. It's a classic. We work a lot as a tire manufacturer with a radar chart. So you have the radar with all the single features: grip, handling, rolling resistance, weight, puncture, and mileage. And you have to decide where to move the cake. You can have it centered or more towards the lightweight and rolling, or you have to play, unless you have some material which really makes that cake bigger. That's the point. With materials, you can have that cake, which is bigger, so you can play with a bigger surface, and so you can achieve more things.
I guess that's the challenge for the whole tire industry, really, is because everyone wants to have the lightest tire, the fastest rolling, the best puncture protection, and I suppose the answer to that would be that those materials just don't exist. You can't have the best of everything.
Yeah. But there is improvement, to be honest, because in the moment that, if we keep the radar chart as an example, in the moment that you have a material which allows you to have a higher performance, maybe in rolling resistance, the overall area that you have to play with, it's bigger, so you can decide again to use that advantage in favor of other characteristics, because maybe for that target user. So imagine I make a practical example. If I have a chemical which allows me to have 50% better rolling resistance, just by chemicals, because of the hysteresis of the material itself, then I have to decide if to use that advantage all and only for the rolling resistance, make a tire a lot faster at the same of the others, or I can use other chemicals to improve the grip, because they are compensated by the better rolling resistance of that chemical. So I go back to the design board, deciding how I want to use that advantage that comes from a single material. It can be a textile, it can be a polymer. It's basically either of the two, or it's a polymer or it's a textile material.
That's amazing. I'd never I never even crossed my mind to think that by having like an amazing area in one sense, you could almost keep that and use it as a trade-off for other areas. I've never looked at it like that. That's really interesting. So I think it's fair to say over the last 10 years, maybe 5 years, gradually we've seen the trend that tyres are getting wider and wider and wider. We've gone, I don't know, go back in the day, people would race on 19mm tyres, then we had 23s became normal, then 25 became normal, then 28s is pretty much the standard now. And every time there's been that shift up a tyre size, it's kind of coincided with a shift up in wheel internal rim width. So it feels like I got to ask the question of when is it going to ever stop?
Another tricky one. Let me put it this way. You always see the two things, so tire width and rim internal width chasing each other. And there is a reason for that. Then I will come to the point if it's going to stop and when. But I'm positive on that. There will be a point where we will stop. One thing which I think is interesting for everybody to become aware is that in the moment you widen the rim internal width, you are basically enlarging the base of the tire. So you are changing the shape, the profile it has. It becomes more, let's say, with straight sidewall, which is good for the aerodynamics. Everybody knows. It's not that good for the handling and the comfort that you get. So the ability of a sidewall to absorb and deform in that sense, if it's straight or if it is open, it's slightly different. It's something that has to do a lot more with the feeling. So we go back to the first point, than with a measurable difference, because the differences are not that measurable, but the feeling it is. So from a tire that has the sidewall straight, you get a more, let's say, rigid feeling, more direct feeling, which for someone is good. Racers typically, for the majority of people, is not a good feeling. So what happens? That the tire manufacturer, they start to make the tire wider again to accommodate the difference and go back to a more, let's say, comfortable shape of the tire. Then the bigger volume is better, so the rim manufacturer gets wider again, and the tire manufacturer goes wide again. So that happens, I mean, to my memory, and I'm in the industry since 17 years now, at least 3 times.
Yeah.
So is this going to stop? At some point, yes. And I use mountain bike. It's mountain bike that makes me confident, because mountain bike has seen that already going to 3.0 tires, so the big balloon, the fat bikes. Then there was the semi-fat. They went back to semi-fat, so 2.6, 2.8. And now I would say that finally, from cross-country to downhill, everybody is set on the real 2.4. So that looks to be the 2.4, the sweet spot, because we have seen the curve of getting wider and wider, going up to the maximum and then coming back.
So on the road side of things,
on the road we are still going up probably. So we haven't seen that happening, that lowering happening again. So I take the mountain bike to be confident that will happen to road bikes. Also, at which point of the curve we are, I am not sure. It's my personal feeling is that we are close, but maybe we will go 32, 30, 32, 34.
Yeah.
And then maybe my bet would be that we go back and we sit down between around the 30 to me. So 28, 30 would be the center probably, with the current 21, 23 millimeter inner width. So that could be, but that's a personal bet. What is sure is that mountain bike already did reach the peak and then came back to what is considered the standard and the best compromise now. The road didn't do the full curve yet. So there is still...
We're lacking behind. We're behind mountain biking a little bit. A little bit. So when it comes to people setting up their own bikes and tyres, is there, like, what's the sort of common mistakes that you see people making that are perhaps easy to fix? Is it pressures, how they're installing them?
What are pressure by far? inflating pressure by far, it's still the larger factor that influences your tire performance. Whatever tire, whatever manufacturer, whatever model you take, a wrong inflating pressure. And when I say wrong, it's wrong for the purpose and for you. So it has to be defined by your body system weight, so body weight plus the bike itself. If you are bikepacking, it's more intuitive that the weight is, has to be considered the body plus the bike, and the use. It's far greater in terms of importance than the tire characteristics.
You know, if someone goes to upgrade their bike, they're going to go, right, I'm going to get some new wheels. But what happens is they buy expensive wheels, and at the same time, they coincide that with buying expensive tyres and inner tubes. And then they put it all on their bike as one and think that it's the wheels that have made the big difference. But I think, if I'm honest, a large proportion of the advantage that they're getting is coming from the tyres. They just don't realise that.
Yeah.
You could have just left the wheels.
Yeah, there is a third factor which I didn't mention, but at a certain point can become less obvious but as important, which is a good floor pump with a pressure gauge, which works.
Yeah, that's important.
This is, I would say, less effective for mountain bikers because the tolerances, they depend a lot on the terrain. So having a plus or minus 10 psi, it changes the ride, but not completely. But with the roadies, where 2 or 3 psi can make quite a big difference in terms of feeling for at least the expert riders. And 2 or 3 psi tolerance is by far smaller than the gauge tolerances. So if you try different gauges, floor pump expensive, floor pump of a different brand, a floor pump cheap, and then the separate gauges, and then maybe you go to a gas station and you try one of the others. In theory, they all should give to you the same pressure they want. And the differences will be far great. So this is another point where some education should be done more for roadies. So who buys expensive road bicycles and take care about the performance? It should be mandatory that they have a good quality pressure gauge.
Okay, that's really interesting to hear you say, because that was almost going to lead on to my next question, which was, what would be the better or worse out of the two? A low quality tyre at the correct pressure, or a high quality tyre but at the wrong pressure? Like, what would be the best outcome there?
From a pure, I would say, manufacturing standpoint, I should say the better tire. Also, given our brand, which is more positioned on the high end, so I should say buy the most expensive tire you can buy. But the reality is the opposite. I have to be honest here. You will get a better experience by a cheap tire at the correct pressure than the other way around.
But I guess if you look at it on the flip side of that, if you want to get the best performance possible, you have to choose a tyre that's designed with the purpose in mind for what you want, and you need to run it at the correct pressure. Something that I have seen a lot of people doing is people maybe head out to their local bike shop, they've looked across all of the different types of tyres that are available, they've made their decision maybe based on price, like we first spoke about. They've gone, look, I want the best tyre. I'm going to assume that if I spend the most, I'm going to get the best tyre. So, but then the mistake that I feel people then go and make is put a £5 or a £2 inner tube into their high performance tyre. And you think, well, you've just spent all of this money getting a tyre which is carefully designed, it's lightweight, it's got low rolling resistance. And then if you add a butyl inner tube, are they throwing away all of those performance benefits?
Yes. So, direct answer, sorry, but yes. If we are talking extremes, so a really cheap butyl inner tubes can really destroy completely the performance of a tire. Then if you're looking or buying, let's say, a high quality butyl tube, so we are talking already around 60, 70 grams butyl road tube, if we do that example. The difference is they are still measurable, and I think the majority of us will feel them, but they do not become massive to the point to say that it doesn't make sense to do it. It's related also to the type of terrain, of course. How often are you going to puncture in relation to how much money you spend? But if we are talking performance, I would rather do the opposite. So buy, let's say, mid-range tire and put the best inner tube I can, other than doing the opposite as you described. Because yes, the tube can influence a lot. And not only because we are talking about rotating masses, which is, of course, that is the same with the tire itself, but also by the energy management thing. So the hysteresis that we mentioned before, it happens also for the butyl inner tubes. So it has an hysteresis. And normally the formulation of the butyl tubes, they are not designed to provide a really great rolling resistance. So they are not designed for low hysteresis. So there is normally a lot of them.
No, that's interesting. A couple more that I just want to finish up, because I know I'm mindful we've been here talking away about tyres for a long time.
Yeah.
Something that I'm particularly interested in, because I think the number of tyres that I've used over different bikes, all the different years, can bike tyres actually be recycled, or is it an unfortunate thing that they're going to need to go to landfill?
Simple answer to bicycle: yes, it's possible to recycle them. It's more a matter of building the whole channels of collecting the tires, giving them to the right manufacturers that can separate the materials without wasting more energy than the one that you get out of the reuse, which is another point. So it's complicated, but we are getting there. And bicycles, again, there is no regulation on collecting wasted tires. That's another point. While for car and moto there is, with bicycle we are behind in terms of regulation for sure.
Well, no, that's a really interesting point. I think an important topic to end on. So I think we've spoken through pretty much everything I could possibly think of, and it's been really helpful to have your insight into some of these sort of questions, and hopefully has answered questions that people at home will have regarding their tyres, and cleared up how to make sensible and informed decisions to try to improve the characteristics and the fun and enjoyment everyone gets from their bikes. So well, thanks very much for your time, Sam. That's been really helpful.
Thanks to you for the opportunity and for the question. I hope it's been useful for everybody.